This video focuses on learning objective 6-6, which is that you should be able to outline the advantages of digital transmission and storage of information. And really what you need to be able to do this is just know what analog and digital are. Once you know the difference, I think it's going to be pretty obvious what some of the advantages of digital are. To really understand what analog is, we got to kind of go back in time a little bit. And a lot of this is going to ask you to really think about what the world was like not even that long ago, maybe 20, 30 years ago, before the invention of any sort of home electronic devices, basically when we just had cassette players in our cars for listening to music and stuff like that. And so what we're actually going to use is even further back is the record player as our first example of analog. So the way that the record player works is that you have these tiny little bumps on the surface of the record. And if you zoom in, the surface is going to look something like this. And there's a needle attached to that big cone, whatever it's called. There's a needle that is going to move along the record, and it's going to track these bumps. And as it does that, it is connected to a sort of like a membrane, this big flat surface. And so as this moves up and down, so will the membrane, and that's going to push on sound molecules, causing them to vibrate up and down. And that sound is going to be amplified as it comes out of this tube here. I don't know what that's called. And it's going to create sound waves that look exactly like the surface of the record. So the texture of the record matches the shape of the sound wave. What's really cool about records is actually, if you think about how they're recorded, it's basically the exact opposite. So if you just reverse this, you take a sound wave and put it into that megaphone, and it uses the needle to essentially cut those little grooves into the record. And then the record is kind of solidified and hardened and then shipped out, and you're just repeating that process backwards in order to play the sound. So what's really cool about that is that this signal that you get, this analog signal, is information represented with an infinitely variable physical quantity. So in this case, the sound is actually being represented by the height of these little bumps. And that can be any height. And so it's this infinitely variable thing. You're getting an exact recording of what it sounded like in that room. With all the background sounds, everything exactly reproduced. And you have just infinite options for what that sound sounds like. That's not true with digital, as we're going to talk about in a second. Other examples of analog are like this thermometer, which is where we have temperature represented by the height of the mercury inside, and it can go to any height. Or this clock, or this picture, where we have just these real physical representations of our information. Now, on the flip side, we have digital. This is the new one. So digital is kind of based on the idea of binary, and I want to take a second just to teach you a quick lesson on how binary works. So binary numbers are represented as little electric circuits inside the computer, and those electric circuits turn on and off. An on represents a 1 and an off represents 0. So because computers only have these on and off switches, the only numbers a computer can really represent are 1 and 0. And so rather than our system of counting, numbers on a computer have to actually count in binary. So let's think really quick about how our system of counting, base 10, works. So basically it's all about place value. So you've got like the ones place and the tens place. And if you put a 1 here, that's 1, 1. If you put this symbol, you have 2, 2, 2 1s. If you put this symbol, you have 3 1s. And you can fill that up all the way to 9 1s. And then if you add one more, you now have 0 1s, and you have 1 10. Or you might have, this number, which is 2 10s and 0 1s, or 2 10s and 2 1s. So it's all about these place values of ones, tens, hundreds, thousands, on and on and on, and then you just write how many of them you have. But if you really think about it, there are only 10 numbers in our system: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Anything other than that is just a number carrying over into the next place value. In binary, there are only 2 numbers, only 0 and 1. And so let's think about what the place values are for a second by using some examples. So this is the number 1 in binary. Technically, just like a base 10 number, there's as many zeros to the left as you'd like, but I'm just going to use 4 for right now. So this represents the ones place. This tells us that there is 1, 1, and so the number is 1 in base 10. This here, we have the ones place, and here's the twos place. So how many 2's do we have? Well, we have 1, 2, which makes this the number 2. Over here, we have 1, 2, and 1, 1. So add that up and you get the number 3. This is the 4's place. So we have 1, 4, 0, 2's, and 0, 1's. That's the number 4. In this one, we now have 1 in the 4's place and 1 in the 1's place. That's the number 5. 1 in the 4's place and 1 in the 2's place is the number 6. 1 in the 4's place, the 2's place, and the 1's place is the number 7. And a 1 in the 8's place is the number 8. So that's kind of how binary works. Obviously, numbers in binary are way longer than when they're written in base 10, but that's okay because computers can send these signals extremely fast, and so they're able to communicate way faster than humans can, even though their numbers are so long. Now, the way that we get digital sound, for example, is to take an analog signal and turn it into digital. And we have to do that using some kind of conversion. So in this case, you can see the analog signal from my record drawn out as this wave shape. This is the analog, exactly what sound was recorded. But the computer is going to take it and break it into numbers. So this is like a height of 0 and a height of 1, and a height of 2, and a height of 3, and a height of 4, and a height of 5. And it's going to represent each of those with a binary number. And what it's going to do is just record what value, what height we were at that second. And so this is a height of 2, and so we're just going to draw 2 as our digital input. We're going to write that number. Here the height was 0, so it looks like that. Here the height was 4, so it looks like that. Or sorry, that's actually 3. And here the height was 5, so it's going to look like that, and on and on and on. Now, one thing to notice about the digital signal is that we lost stuff. When we changed the analog signal into a digital signal, and this is true anytime you're recording any digital information, you are technically losing some of the information. If you take a digital photograph, the same thing is true. You are losing some of the information in that picture, and because you're having to turn it into pixels, and each pixel can only be a specific color. And so a digital photograph, again, if you zoom in close enough, you're just going to see these little dots and pixels. You've lost some of the information. Now, obviously, we can fix that by using higher and higher resolution, using smaller and smaller pixels, and so it gets more and more like the analog version, but digital always loses some information compared to analog. All right, so let's summarize. Now that we know what digital is, we know that it's the language of computers. We know that it is a summary of a physical thing, whether it's a photograph or a sound. What are some of the advantages or disadvantages? Well, let's start with analog. Analog does carry all of the information. So analog can technically be a more accurate representation. And analog can also be a really secure choice. If you want to keep that recording perfect forever, then sometimes putting it on an analog record and just putting it in a box somewhere is the safest thing you can do, because it does protect it from things like digital piracy or hacking or whatever. Now, on the flip side, you have the advantages of digital. So digital is extremely easy to copy. Think about copying a record. You have to actually cut a new record, a physical thing, or make a new CD with lasers. I don't know if any of you have ever, created a CD in a computer, but it takes some time. And if you think about record companies making enormous numbers of those CDs and then having to ship them across the world, that's difficult. The other big difference then is like storage of the information. You can store a ton of digital information in a very small space. You can't do the same thing with analog information. And then the last big advantage of digital is sharing. We're now at a point, and I got to tell you guys, this is completely ridiculous. Like, part of me thinks back to when I was in high school and I got my first CD player. You had to pay about $15 to $20 to buy a CD, and then you would put it in your CD player, and you had to be careful not to shake the CD player or the song would skip. And you'd have to put new batteries in it like every couple days because it would run out, and you would be stuck with just that CD, maybe 12 songs, and that's probably all you listened to, while you were at school in the passing period. And pretty much you would listen to it only walking to and from school because that's about how much battery life it had. Fast forward to now, I can stream real time any song in the world from anywhere. It's completely insane. And it really shows you like the advantages of digital and why the world has gone digital. Are there still some people who use Polaroids and records? Yes. But the reality is digital has a ton of advantages. Now, I do want to circle back and highlight this one. We need to remember, on the other hand, that digital has some significant disadvantages in that it becomes very hard to control. And so if you're an artist who is making music, there were some really nice things about the fact that people used to have to go to the record store and buy your song, whereas now they can just listen to it for free on YouTube. But that's where the world has gone.